let's talk about AI's ability to think. So machine learning is typically at the brain of most artificially intelligent systems. Machine learning platforms are these software or libraries of machine learning algorithms. There are many different types of machine learning algorithms. Deep learning, artificial neural networks, a type of machine learning. They deserve kind of their own call out because they do something quite special. But in classic machine learning, you have classification like decision trees. You have clustering models to find different maybe segments of customers, often used in customer segmentation, association analysis, you guys would probably know as market basket analysis. All of these classical machine learning systems. Now, the one thing that I want to make clear here is that the algorithms get a lot of the hype. The algorithms are really sexy, but the algorithms you can access in open source in R or in Python, or you can use a proprietary tool like SPSS or SAS. The algorithms are pretty much commoditized. It's the data that you feed into an algorithm that creates a model. So your differentiation from machine learning is actually going to come from your data. I can't stress that enough. It's really not that much about the algorithm. Everybody has pretty much the same access to the same algorithms, except for maybe Google and Amazon. Deep learning, this is a convolutional neural network here. You have an input layer. You have these hidden layers in the middle that are made up of perceptrons or neurons, they're sometimes called, and then the output layer. So we were talking yesterday about how people always use the image of cats as an example. So I don't want to fall victim to that. So maybe images of hamburgers. And then in these hidden layers, they're actually picking up on features that say, okay, this is a hamburger. Like maybe this is the bun layer, and maybe this is the meat patty layer. Maybe this is, there's ketchup on it. Actually, it's probably more like, okay, here's what the edges look like. Here's what the shading looks like. But through a process called backpropagation, the network actually figures out, okay, what are the key ingredients of a hamburger, and gets really good at predicting whether an image is a hamburger or not. And until recently, we couldn't really use deep neural networks, not because they didn't exist. They've existed since the 1950s, but because we didn't have the compute power to train the algorithms to do what we want them to do. And also we weren't applying them to unstructured data like images. Now we have GPUs, and it makes this process a lot more efficient. Finally, action. What are the technologies that help us act? Well, one of the main ones is natural language generation, which is if you're in a conversation with a chatbot, instead of just yelling into the wind, you actually get a response. The machine is actually generating a response. Many of these were actually initially adopted to feed in like a box score from a sporting event, and then automatically create a news article on that match or game, as if journalists didn't have it hard enough these days. And then finally, there are a few solutions in our research we identified that combine all of these elements to some extent. They sense, they think, and they act. So if you think about the previous technologies as technologies or components or building blocks of AI, well, these actually fulfill the requirements of being AI in the sense that they're, to an extent, continuously learning. So one of these is AI-enhanced analytics solutions. So BI tools like Tableau or Cognos, pretty commoditized feature-wise at this point, but they've realized that by employing elements of AI, natural language understanding, the ability to automatically identify anomalies that a user may be interested in, they can get some differentiation. So we're starting to see partnerships between Tableau and automated insights, and we're seeing some companies build this into their BI solutions natively. Conversational service solutions, and would be a good example of this. These are customer service chatbots, essentially, and there's a whole suite of technology providers who specialize in just this. This is most enterprises' first foray into AI, I would say, are these chatbots for customer service. Intelligent research solutions. Here, these are solutions that are disrupting traditional market research. and allowing folks to actually have a conversation with a chatbot about their experience rather than answering survey questions to get a more nuanced view of what the customer experience is, what's driving that customer to buy or churn or have a different experience. Intelligent recommendation solutions. So we're going to see kind of like one of the most popular recommendation engines in a second, but most recommendation engines rely on something called collaborative filtering, which says that if Mary and I look alike, you're going to show me content that Mary has engaged with. These go beyond that. Sometimes they're using image recognition to actually show me, let's say, shoes on Zappos that look like other shoes that I've seen. So it actually doesn't have anything to do with the user. The recommendation is totally based on the image. What does the heel look like? What type of material is it? What color is it? And then pre-trained vertical solutions. Pre-trained vertical solutions is kind of a catch-all category for any sort of plug and play machine learning where you don't actually have to do the training yourself. So Watson for oncology, for instance, IBM bought up all these medical imaging companies so they could train Watson to identify cancer from those medical images. There's another great company based here in California. It was a young kid at Stanford created something called Do Not Pay. Have you guys heard of Do Not Pay? So if you get a parking ticket in the United States, or I think the UK, you can submit it to Do Not Pay, and Do Not Pay has been trained in all of the municipal parking code in those two countries to actually fight your ticket. And something like 76% of tickets get some sort of reduction by using this service. So anyway, that one's pretty interesting.